Okay, welcome back to the workshop track 1. Next we have a workshop from Clemens Portale from Interactive Instruments and Jari Reini from National Land Service Finland about the new OGC API features.
Okay, so thanks for coming after lunch. It is about two parts actually. One is the OGC API features, which Bart already introduced yesterday, quite in some depth, but we'll get a little bit more into the details of that. So that's one thing that we hope that you can learn, and the other thing is also using an open source product, LD Proxy, which you can set up on top of existing web feature services, so you can play with that with relatively low effort. And we're going to show that, and maybe some of you will also try it yourself. We'll get to that in a minute. So here's an overview of what we're doing, a quick introduction, a few slides on OGC API features. I guess we can keep that short. And also, since this is an Inspire event, Jari will talk a little bit about the discussions that are ongoing in the MIG-T on that. Yeah, then we'll show how to set up actually LD Proxy. And then play with it, set up an API based on existing web feature services, configure that a little bit, explore the API, have a look at it, have a look at OpenAPI, and then also Jari will also show accessing that from other clients, so QGIS and OpenLayers, I think that's basically. And then we can have questions and discussion. I mean, if you have questions, please interrupt at any time. We can get to that at any point. And if we have time, I can also talk a little bit about some extensions that are actually implemented in LD Proxy that are being developed concerning vector tiles, styling, and also several extensions to features. So that's basically the program. And let me start with a quick introduction on OGC API features, basically the first part, core. So that's basically a rehash to some extent, but also some new elements of what OGC API and OGC API features is, and what we are changing if you are familiar with WFS version 1 or version 2. Basically the idea is that we define modular building blocks for APIs, so that it's not isolated services, but things that you can use in any kind of web API. We'll maybe see that a little bit later, but it's quite a change in the approach. And there are some aspects on when we talk about modernization, and that's why it's also probably fitting that it's no longer called WFS 3, but OGC API Features, because the capabilities are still very similar. So you're still accessing geographic objects, spatial objects in Inspire on a fine-grained level. You can query that, etc. But it's quite a different service architecture by following the web principles. Bart introduced that. We leverage OpenAPI, and I'm going to show that as well, and also why that has benefits, or in particular for those people who are not here, who are not familiar with Geo, who have never heard about WFS or OGC API, and that makes it much easier for them to actually work with this stuff. What we also acknowledge is that the web means HTML. Bart, I think, mentioned that as well yesterday. Make it indexable, so search engines are one thing, but also leveraging the browser. Most of our current services don't work well with a browser. You have to use special tools to actually do anything with that. We remove XML. I'll have a slide on that. And also the focus in general on the developer experience is important. that we have there. And actually, last week, the first version was actually published. It was approved in September, but it was published last Monday, and since then everything is on there. There actually have been relatively few changes since April 2018. These were mostly the details. You saw some of that already on Bart's slides yesterday. It's basically 6 resources that we have. So each resource has a URI, and then you can get the information, or in extensions, you will also be able to add features and things like that. And we can actually separate it into 3 basic parts. So the first 2 is just a landing page that just gives you links and informs you, and conformance declaration just informs which conformance classes are supported, so that a client can determine what I can do with the service. And that is true for every OGC API. So that will be the basis for every, even if it doesn't do anything with data, if it does processing or whatever. And then the next level is basically a description of data. So you can get an overview of the collections. So one of the other things that we did is, if you know WFS2, you have to have an XML schema to do anything. And that doesn't really reflect how people often work today. So you can publish schemas, but it can also be schemaless. And you may want to publish collections that contain more than one feature type, where WFS was very rigid, feature type oriented, which is also very schema based. And that's more flexible now, although most implementations clearly still use a feature type concept in there. So you can get information about the feature types or the collections that are offered by a service, and then finally you get, and that's really the only feature specific thing in there in terms of accessing features, is access to multiple features or also an individual feature. Every feature has an individual URI, so you can link to it. But also the information about the collections, that is something that you also need if you want to get maps. So basically the new WMS or the new WMTS or vector tiles, it's the same data, you still need that information. So the only thing that's really specific to access to features is the last one. Finally, something on XML. So that's just Google Trends. And if it's on the left side, that's 2004. That's basically when the first Inspire discussions got more concrete. I think 2005 we started drafting teams. So that was no JSON and all XML. And you can see a dramatic shift in there. And if you go to basically the web developer community, they don't want anything to do with XML. They only want JSON or YAML, which is kind of another representation of that. So it is also important that we actually make the step away. I mean, we can still support, and OGC API-Features supports XML, but you don't have to use it. And actually, most implementations, I think, will probably focus on JSON. There is another thing. So what we're trying to do is do 2 things at once. One is the left side. That's basically the standard GIS community. So there are 2 ways in how you can actually use the API. The one is if you have someone who knows the standards, you start at the landing page, you can follow the links, you get the content, and by that you can use the API. And that is, of course, like, for example, what a standard, if you have a QGIS module that relies on that, right? It doesn't, and that allows it to actually access multiple endpoints that implement that standard. The other approach is actually that you use the Open API definition to describe the API. So a developer who has no idea about geo, he probably doesn't know about any OGC standard, so he will get to an API, read the Open API documentation, and the definition, and use then the tooling around that to generate code stubs, etc., and develop this app. So one of the goals is that that community, which was mentioned yesterday quite a bit, so that we have to make it easier from the non-geo experts to actually make use of our data. That is exactly the way we want to do it, where so far most people had to read WFS, filter, GML, so lots of standards. The hurdle is very big, and that should dramatically lower the barrier for that. So in the data on the web best practices, there is actually the term time to first successful call in there. And so how long, I think yesterday was like this 30-minute test or something like that. That's very similar to that. So how long does it need that you can, how long do you need as a developer to get something useful out of an API? And with WFS, if you have no idea about anything, it's quite a bit, and that should lower the bar. That's a big important goal in there. So what's next? I think I can make that short because I think you covered that mostly yesterday. You mentioned the sprint on queries, filters, CRSs. That's what we are working on, transactions, and all these other resource types that exist. Another important thing is that basically, I think what you will see from OGC coming in the future more is, so these web APIs are basically, you access a web resource at a URL and you get something back. And you can also interact it with post, delete, patch, and all these other HTTP mechanisms. But the other thing is more the event-driven. So something happens and you tell someone. So Internet of Things type, or let's say change-only update in the feature case. So you don't have to pull all the time, but you can also get messages. That will be, I think, an important thing. There is also, we have Open API, there is something like Async API that does the same thing for event-driven APIs. So that's also something to be aware of. The approach that we're using, as I mentioned, we'll set up a proxy. So we have, on the lower end, we have our SDI, here WFS2 with any complexity in the model, any CRS, GML, XML, very rich queries as it works today, and then the bridge to the more web type approach. I don't go into detail. I'll show that. And before we go into these details, we'll switch to a few words about. We have it on Inspire and OGC API.
Thank you, Clemens, for that nice introduction about how OGC API-Features works, and also Bart has the same intro yesterday. And now we may wonder what this has to do with Inspire. It's a new way of delivering content, as Clemens clearly described. And what we have done in Inspire MICT as well, we have looked into possibilities how to use this new API in Inspire context. As Clemens mentioned, the standard came out on 14th of October. Clemens is one of the editors there as well, so he knows everything about this. And what we've done since the standard was published, and also before that, we've been looking into how to use this new standard in the context of Inspire. So if we are looking from the left-hand side, we have as an input the standard itself, and we have Inspire implementing rules. Then we have put our heads together with colleagues from JRC, from NLS Finland, from Danish colleagues, from the agency I'm difficult to remember, but formerly known as KMS, now something SDFE, nevertheless from Denmark. So we have done some work related to how to update technical guidance for download services to have this new OGC API in place. So as most of you know, Inspire implementing rules. I won't give a lesson about that. I could open the implementing rule PDF document, but I just have a few slides. And there are, as you know, several different operations mentioned in download service implementing rules, from which you have two first here: get download service metadata and get spatial dataset. And there are on the left hand side some inputs. So how can we have these input parameters so that we can have an output by this on the right hand side? And there are others describe spatial dataset as well as link download service. So now if we touch a little bit what is required, and additional direct access download service, get spatial object and describe spatial object type. I'm pretty sure you all are aware of these 6 different operations. But how we map this to Inspire? First of all, we have very important principle what we didn't have during the OWS Common or capabilities world, that we made some extensions which may have caused issues for many of the service providers. So we do not accept any Inspire specific extensions. So we use Open API or OGC API-Features directly and try to map the functionalities and what is given for us already, and to map it so that we are compliant with Inspire implemented rules. As such, we use this as intended, not to do any additional things. Well, that's not directly correct, because we may need some coordinate reference system extensions, but we will cover that later on, and it's already work in progress related to OGC API features. So what we have done in the last year, we had first a discussion paper about some examples how to map, how to use different resources and how it can work in Inspire context. I don't go into the details, there are new versions have come as well, but we touched a little bit testing real implementations which are available, and I believe Clemens will also show some real examples during this session that you can play around with this API as well. But we looked into different kind of issues. One is language support, and as it stated in implementing rules, language must be there to be what are the languages available, what is the request language, etc. So by default we used in the current technical guidelines, we used these extended capabilities, and in this we are following the way that we use HTTP content negotiation, in which you can define or send a request parameter as a content negotiation, and then to get back what is offered. So as an example for content negotiation, so you first send a request to the service, and in the message or in the GET request you have accept language, so kind of asking, please give me GeoJSON or GML in Finnish, Danish or English or whatever language you may have in your mind. And here we have FIDAEM that will be sent to the server side, and then the server is figuring out what is available there and returning, in this case, language or geolocation in English language. So that's the way how to get language support in OGC API features used in Inspire field. So there are three different things. We need accept language, we need content language, which is the response, and then we still have a little bit question mark how to define supported languages, but we will figure out it somehow. But we are really believing that this will work out well. So in this language request is an accept language, vice versa. Response language is the content language, and then supported language is still working in progress. Then also we have often had the question of getting the whole data set. By default, WFS old versions are not meant to be used to download the whole transport road network from the Netherlands, for instance. It's quite a big amount of data. So web feature service itself, as the name states, is more for features, not for getting the whole data set. But in Inspire implementing rules, one must get also the whole data set. Many of us as the data providers have been using Atom feeds, and in this context, when using OGC API features, one way of implementing that could be to have a relative link as well, for instance, to GeoPackage or some other format to get the whole dataset through this collections definition, or old-fashioned, I would say, get capabilities document, which should have a link directly to bulk download the whole dataset. And that's what I'm going to say about this, except that there will be some extensions which are required, and based on that I believe we have everything in place in order to be Inspire implementing rules compliant. We had a meeting last week in Prague, MIG-T meeting. We had a little bit more slides there and more topics for different dataset IDs and others, but I don't want to ruin the session by going too much into the details on that, but now we can continue and see how this actually works. So back to Clemens.
Okay, thank you, Jari. So that was the last slide that we have. So from now on, we'll try to do more hands-on stuff. What of interest, who of you wants to set it up yourself? Who's prepared to run that on Docker? Okay, 1, 2, 3, some shy hands. Okay. So what we're doing first is actually that's the page from the workshop description, and we're going to set it up on our local machine. The LD proxy software that we've seen, it's using Docker. That's the container software that we're using. So let me, so there is, let me get here. So basically that's the command that sets up, let me get that a little bit bigger. It starts, container or image, gives it a name, LD proxy that we're using. It maps it to port 80. It loads it from Docker Hub. It gets the latest development version of LD proxy from our Docker Hub organization. And then we need a local file, local directory where all the application files can be stored. You don't do that in the container itself, because when you want to do an update, that gets replaced and you don't want to lose all your work. So that maps it on here on Windows. to a local directory. Since I'm not using Windows, I'm actually using a slightly different directory. But then when I run that, it actually, I removed it locally, so it doesn't find it locally. And now it starts downloading it, and it will start it automatically. For those who,
just for those who are maybe using Windows Docker version, when you are trying to get the content, you must share your C drive. So there is in Windows for Docker, there is a settings window, and you must access drive share for this container. So otherwise it won't be successful. That's all.
Okay, so now it's downloading, it's 85 megabytes, and it is starting it now. So now the process has actually started. We can see it here. There is also another PostgreSQL, PostGIS container running, but it's starting now the LD proxy software. So for those who actually set it up, if you got the image between Monday noonish and this morning, we introduced a bug on Monday that has a slight impact on that. So if you did it in that time, you may have to do another pull to update the request. So it should be started now. So let's go. Let's close all this. So let's just go to localhost. And then it actually redirects. There's another problem in the current, it's a development version. You have to log in with admin. So that's the initial setup. Don't save it. Okay, I already have one. Didn't I delete the container? Okay, let me do a quick fix. So I can start from scratch. Now I'm stopping it. Remove it, and now I remove that local directory again, and I restart it.
And that's the way how you update
the new latest version.
Correct. Then if there would be a newer one, you would be getting the new software, and so now it needs a few seconds to actually start up again. There it is. Again, wants to know who I am. Maybe I'll say that. And now that's what you typically see. So what we're doing is we're setting up a service. There are more capabilities which I'm not going to really show in the session here today. So to set up a new service, you press the plus sign, and basically the two things that you have to provide is an ID, at least 4 characters, and the get capabilities URL. Let me try to set up 2 different services. One is from the Netherlands. That is just some landscape data. Let me add that, and then it takes a while to set it up because, as you will see, it's actually analyzing the GML application schema to get to the properties and all that information, and that has, I don't know, 40 feature types, so that takes a while to download everything. So in that meantime, let me also take an Inspire server here from Finland, from the environmental agency. You can do that in parallel. So let's set that up as well. And you can see, all right, that one is set up now. There's a green. You will get a red one if and that's unfortunately the case. Many servers have invalid GML application schemas. And then because we have to analyze the schema, then you will get a red flag and it won't start. So you can't use that service. Unfortunately, quite a few WFSs have that problem. You will get an error message for that. But then you actually have to fix your schema, if it's your WFS, or you have to talk to the people who actually have the WFS. So let's just have a look at it. Okay, you can click on it, and then there is a home button there on the right-hand side, or you use REST/services, and then the ID that we use, the landscape atlas. And that's basically the landing page that we're getting, and that's the HTML representation. You can also get that uses content negotiation. So if I say accept applications/JSON, then I would get the JSON version. Let's have a quick look at the JSON version. You can also override that so we have clickable links. But basically, that's what I said, the landing page is basically just a list of links to all the things that are on that server. So we have the title and the description. That's what we see here. That's just an HTML rendering of it. We have a self link. That's just common practice, so that if you move that document somewhere else, you always know where it came from. What's the ID of that? We have links to alternate links, okay, and that's basically to other representations. Could also be to other languages. So in that case, we have the link to the HTML page. Then there are the API descriptions that we have, the link to the conformance declaration that we saw, and the links to the collections link. So we can explore those. Let's start. If we remember the slide with the resources, where we click to the conformance link. Basically, again, since we're doing that in the browser, if I click on the link, it says, give me text HTML or give me whatever, and if not, decide what you give. And that's why, by default, it returns HTML. If we would say, again, give me JSON, then you would receive JSON back. And again, and basically this just implements 4 conformance classes from OGC API-Features. Right? And these are all URIs, and at some point they should also redirect basically to the spec. That has not been set up, but basically a client can see this is the core, and we support GeoJSON and HTML, and we support OpenAPI. So for those who have actually set up an instance yourself, were you successful in getting something updated? Yeah. Did you try it with one of the WFSs that I provided, or with, yeah, okay. I mean, you can also use that to see how it works with your WFSs. One thing to mention is some of the WFSs, so one thing are these invalid application schemas. Another thing that can cause trouble is if the WFS2 doesn't support the start index parameter. So basically then you can't do paging, because the only chance that you have is get something, but you will never be able to get incrementally all the data. And then actually the City of Hamburg WFS that I have, that doesn't have paging, so you will never get a next page link in that. That's then the result. So that's the HTML version. Let's also again have a look at the JSON. That's pretty unspectacular. You basically have, again, that's pretty normal that you have the self and the alternate links, so that you can always know what is the available, what other formats can I get. And that's also something that could be used, for example, for languages, that you can always say, I have this document also in Finnish and German, right? That is one of the possibilities. And then it's just the conforms to links that we have seen. So let me get back. So that's again the landing page. So let's go to the collections. That's basically this link that is also, so that gives an overview of the collections that are on that server. And as I mentioned, that one has quite a bit. Most of the words will say more for the Dutch or Belgium people in the audience than to me. And also you can already see, well, currently we label it as expert information. For example, we have this server supports already the other coordinate reference system, so we can get that also in the national coordinate reference system of, we can actually do that later. So you basically have an overview of the feature types on it. Again, let's have a quick look at the JSON that is in there. And basically, again, you see all the different characteristics in here on the CRSs. And then each individual collection, again, you have the links to the data, and you also have temporal and spatial bounding boxes and information about the CRSs. So that's basically, you also have similar things in your capabilities document of a WFS when you show the feature type. So that's basically what you have here, and that's what we show. Here. If we go to an individual, let me go to one. That's the more information part. So then I'm looking at one collection, one feature type. Again, the HTML version, we show the bounding box we basically show on the map. So you can see where that data is. In the Netherlands, again, we have additional information down here. Let's not go into detail there. And then I can access then the different features. So I guess that's windmills, because the nice thing about that data set, it also has links to images, and then in the HTML we show that, so that gives me a hint, and so basically we have that information, and you can see here the paging. That's just like you page on, if you have a search engine, you can also jump to the end, so that actually works quite well and allows you to actually access all the data. And that's then also the link to an individual feature that we have in here. But there, let me show that document quickly. So basically, probably as you would expect a GeoJSON feature, you do have the link to the images. So we show that, and if it's another URI, we actually show that as a clickable link in here. So if I click on here, you probably should get some, yeah, that's then, and that, basically what you're just browsing is a WFS. It's just built in the API, the HTML API is a built-in interface, a built-in client to actually browse the data, where so far you had to install ArcGIS Pro or QGIS or whatever to actually access the data and read it. And if you are not an expert, you first have to know how to find that data, that application, and set it up. So then, and that makes it accessible by everyone, because everyone has a browser. The web uses the browser, makes it accessible to search engines, etc. So that's quite a change in doing that. But of course, when we want to have a, let's say, attractive HTML, we need to do a bit more so that it's useful for users. And we're working on the capabilities to improve that. And I'll just show you. Let's do one example. If I go back to the manager, all right, it didn't start that's one. Interesting. It did that for me a couple of days ago, but you also had problems, right? So we'll have a look at that. So let me give you an example on how to configure things. So first of all, Although we could change the name. That's actually working pretty well in that case. Not all WFSs have human-friendly names. So let's just go to the feature types, and then you see the collections that we have there. Let's go to them. Again, I can change the display name. I don't really need to do that, but if we go back to here, we have a title that just uses the internal GML ID that we see, which is not that friendly. And if we look at it, then probably the name is a nice thing to show. So we can then here, we could switch off support for that feature type at all. Then it wouldn't be shown by the server. And also there are lots of other things. So for example, also for schema.org, that's information embedded in the HTML for search engines. We can map that to different schema.org types, but instead of ID, I can write in nam. Actually, you see a green, it's changed directly. And if I refresh it, then I see the name of the of the windmill. And also, if I go back to the overview page, that works for everything. Or other things could be, let's go back, we have the thumbnail and a big picture, which look the same here, because they're all resized to the same size. So basically, we can actually disable the big picture in the collection view. Just to give an idea, then now the work. All right, that doesn't like to be disabled. So as I said, there are updates also to the JavaScript front end where we obviously have an issue, because usually what you would expect, if it accepts that, then I wouldn't see that property. So sometimes you don't want to see all these properties in the overview, only when you go to the detail. So they wouldn't be shown here and would only be shown if you go to the individual page. So there are all sorts of configurations, and we have quite a few experimental extensions related to that, but usually they are deactivated. And because that's one thing where we are trying to figure out how we can actually create from data useful HTML representations, useful for human users. So let's see, that's basically one thing. How are we doing on time? Quarter past. So the other thing related to that I may show is we saw basically the API. I mean, of course, when we talk about the features API, most of it is nice sugar, but the most important access is the /items path, where we are actually accessing the features, so querying the features. And as we have heard, the core does relatively simple query capabilities. The only thing that we support is actually we can set up filterable parameters. So we could also, the UI doesn't do that. I can show another example at the moment, but I could say I could filter by type or by function, and then that allows me to filter by just that value, not in any predicate with and, or, and other things. And the other two things that are built in is the Beatbox Search, so the most common spatial search. If you have a mapping client, you basically need the Beatbox Search and the date time search. So that's also built in there, and you can do that via the API. And in the HTML, we also do a little bit of support, and we can have a look at how it looks in the API. So let's go somewhere and add that and apply it. And then we're getting far less windmills, just 10 pages of them. basically in the URI you can see that it adds a parameter Beatbox. I think that was also on the slide that Bart has shown, because that's the most typical query parameter that you have with spatial features. So it adds a bounding box filter, so you only get those features that are in that bounding box. So let me have a look. Let's have a look quickly at the GeoJSON that we get back. So you can see here the query, and also where is it? Here's the link to the next page. So that's what we're actually using. Seeing in the HTML, when we click on the next page link, then this is executed, so it gets the bounding box, and it also has a parameter of offset 10. So currently, by default, we just deliver 10 back, but I can increase that as well and say, instead of here it says limit 10, that's the default that we have, and if I say limit 50, then I will get 50 back. We can see that here, number returned is 50, and number matched is 92. So if let's just do that, if I add limit 100, then I get number returned, number matched 92, and no next link. So there is no next page. I have all the information that is available. So that's in GeoJSON, and the important thing is, again, so it works nicely in the browser in HTML, but the important thing, it also works nicely with let's say, it's kind of extended GeoJSON, because GeoJSON has no notion about links, and we basically add the links to be consistent with the web paradigm. And basically you have the links, and you can see even here in the browser, I can click on it, I get something back, I can navigate, and that makes the data much more accessible than it was before, because mostly the browser, if you get the capabilities, how you get to the data, and then when you have the data, you have no next link to the page, so you have to read the standards to know how to actually get then the next page. So that's basically a quick overview of some of the things that we do to actually make it easier to use. So, are there any questions on this concept? Is that clear? Does it make sense?
Is the links concept out of the GeoJSON standard, or is it an extension?
No, the question was, I think it's whether links is part of GeoJSON. It is not. So, but it's a valid, GeoJSON doesn't prohibit to add that. It prohibits certain things, so we can't change what is in a geometry, so we can't add solids to geometry, for example. But we can add, it's legal to add additional members on the top level, and that's basically what we're doing. So that's why also we don't, wrong notebook. So what you typically have is, the typical GeoJSON is you have an ID member that we have here. It always has a type, so it says feature. That's not the feature type, it's the type of JSON object, it's always features. So GeoJSON is really typeless in terms of feature types, and it has a properties field where then you can put everything you want. So basically that's then the attributes of the feature. And since the links are basically something, and what we've also added is this number return, number match, and also the timestamp that we have. Basically then the links we add on the top level, so it's not a property of the feature, it's basically a thing of the response document. In a way, yes, yeah. So it's kind of orthogonal to the feature thing, but it allows then clients to actually, like the HTML client, that's actually a good test to have an HTML client, because if you can't really navigate with the things, if you can't create an HTML that works, then probably also the JSON is not fit so that you can actually use it from a general client. Okay, so let me then show you, let me just quickly see what's wrong with the, oh, there we go. I don't know if something's changed with the WFS, but no?
Nothing. At least not this week.
All right. Unexpected end of file. Looks like a connection problem. Actually, I have it probably a comfort. We'll see if I can get it. Let me do it. Parallel start my local machine. Oops. Why is it not?
But isn't that amazing? You have existing WFS2 service, and then on top of that, proxy, and then you have OGC API-Features, and you can see it via browser immediately. Even though I know many of you love GML, and it's nice to look from the browser or any other Notepad or other clients, but I saw something human readable in a way.
That looks really great, what you just showed.
Okay, great. I mean, that's
Except the
very
error
good.
from Finnish Environment Service.
It's network error. Yeah, the valid XML.
All right, so then let me, the next things that I want to show to you is really the new capabilities file. So as you've seen, some of the capabilities but are in the current code capabilities you've seen in the resources, like the bounding boxes, because bounding box is something, Spatial is special. There are some things that are special that don't fit into the general IT standards that exist, so we actually have to put it in our resources. But most of the capabilities is actually in the Open API definition. So Open API is, let me just quickly show the raw data. So for the capabilities fans, it probably looks quite similar because you have very similar information. Again, it's no longer XML-ish, it's JSON in that case, but you have title, description, contact point, license. Well, that's a simple license here. No license. The link to the endpoint, and then basically, since it's a web API, it's a description of the path structure that you have, then which HTTP methods are supported, descriptions, what you can get back in terms of, so it's basically the full description of, actually much more formal description than capabilities was providing, geared towards how HTTP works in terms of status codes, in terms of methods and operations, how you can interact with the resources. So you see the landing page, and also we have here a schema for the landing page, with conformance, description, again with a link, and etc. That's for all the different paths. Let's have a look at it, because again, as a human, we probably want to have a look at it on a more readable way. And so basically, this is now using one of the standard tools, Swagger UI. There are, I would say, about 10 toolings that can take this JSON that you've just seen. That is a standard. Open API initiative is, that's a part of the Linux Foundation, and all the big players are members of it and support it. So Google uses that, GitHub uses that, eBay, Microsoft, all those players. I think the only one that's missing is Amazon from the big players. SAP is using it. I was actually last week at the first conference for API specifications, and they they are using it all massively. So that's basically just an HTML rendering, but and again, just like that goes back to this. So if I'm a new developer and want to learn how the API works, that basically gives you a documentation of the HTML, of the API. So you can get the information for the landing page. That is simple. I just have the format parameter that we support. But again, what I can do is I can say try it out. I can put in something here. There should be, it's actually an enum. Should be an enum, so you can select it, but let me just leave it away. I can put it in here, I can request it, and then I can see the response that we've seen in the browser, and so I can play here in that documentation directly with the API, and it describes all these resources that we have seen. So let me go to the where are our windmills? Up. Okay, it's there. There it is. So you can also try it out here, and then we get this description of the windmills with the bounding box, etc. The coordinate reference systems. I can show that as well. So let me move down. And here we actually let's access the data. Okay, so let's use the query, and for example, then I can, here you see the default limit of 10. Let's put in 3. I could also actually add a bounding box. That's a bit more complicated because I need to add some items there to actually get. Let's do that. It's a good question. I don't remember really the bounding box that we have, so maybe I'll skip that for a moment. But I could, for example, what we can do is actually, let's get it back in the, that's one of these extension parameters, CRS. That's part 2 of OGC API features. That's not in the part 1, but it's implemented here and in a few other places. So if I execute it, it probably doesn't like that I have the, can I get deleted again? Yeah. So if I execute it, we should, I should have started the bounding box. So let's let me reload the page. Let's just say 3. And the default, basically every server has to support CRS 84, that's WGS 84 long lat, so that, I mean, in particular for the non-geo people, I know that in Europe we say it's ETRS 89, or international you have your own, but on a global level, in particular for most people, in these applications, what you will see is WGS 84, and usually then also in the coordinate order longitude, latitude. So we actually, so that it's easy. The other thing that Bart mentioned yesterday, one important thing is we want to integrate data from multiple sources, and it should work. Now, if I have no idea about geo, I have no idea about coordinate reference systems, and I get data from there, and it's in ETRS 89, and I get data from there, and that's in the Dutch coordinate reference system, I bring it together, that won't work because the numbers don't match. That's why we're actually forced, if you don't know about anything about CRSs, you will always get the data in the same CRS again. So to simplify the integration of the data. If you're familiar with with all the details of coordinate reference system. There are the mechanisms, then you know what you're doing, and you can request it in your other coordinate reference system. So let me get it. And then we should see the coordinates. There we go. We can see that these are definitely not longitude, latitude values. We have in here. So, and so we have the data in that other coordinate reference system. So, and basically also what we have here is another kind of HTML client to it, but built on this open API. If you have never heard about the standards, you can use that to get an understanding of what kind of data are you getting back. So also without the HTML, you can actually play quite well with the API and get an idea. And that gets back to this time to first successful call. That should enable you much quicker than where we are today to actually get to useful calls, get some data back. For example, also if you, and GeoJSON is quite well supported in tools. For example, if you put the data in GitHub and look at the file, you will actually get a map rendered version of it. So it's much easier to get all the data into the mainstream tooling that exists. Any questions on OpenAPI or what I've shown to you? No? Okay. I'm wondering, time-wise, probably we should we switch to the clients, or should I? Okay. Yeah.
Okay, it's also interesting for those who are using more common prompts or more developer background. There are curl, there are Java, there are different SDKs also available which you can use, and then to make a hub for that and then to implement in your mobile device or others. So by this Wacker UI you can actually have a lot of stubs to be used in different operating systems and others, so mainly for developers. But maybe I give you time to have breathe for you, and then I show my examples, and then we go for the questions afterwards. So would you like to show first extensions? I don't know. Okay. We still have half an hour, okay. I believe.
Okay, maybe then I'll quickly show a little bit of the extensions. I'm switching to another server now. Actually, let me go to. So don't be scared that the data is in Syria now. That's OpenStreetMap data from Syria. That's from OGC testbed 15. Some experiments that we've seen. That's basically the landing page for a data set. And the typical thing, I mean, it has the same things that you've seen before. So we have the link to the API definition, we have the access to the data sets, here the feature types, but we see a bit more. So for example, we have access to vector tiles. Let me quickly show that, click on that link. So that is then vector tiles in Mapbox vector tiles format from the whole data set. That's just a demo client, so you can see it's active. It's not an image, but it's actually vector tiles, and you can see the properties of the individual features in here. That's Mapbox vector tiles is kind of a de facto standard that is used by most organizations, including also in ArcGIS. It's quite effective, and it uses protocol buffers from Google, so it's very minimal in size. And I think most of the web mapping applications, Google Maps started in, I think, 2013, and Mapbox and Esri, they all moved over the last years to actually use as background maps, use vector tiles, and because you have the active content, it's much more compact in size. And OGC is working on extensions to do that as well. Let me quickly show then, let's have a look at the Open API description because that provides the simplest overview. So let's skip the capabilities part for a moment and the data part that we have. And then we have here support for tiles. And basically you can see, and that's also pretty standard, that you have a certain approach for templates, how you actually build that. You address the tiles by the level, zoom level basically, and then the row and the column. And then you can also select different tiling schemes, which depend then on the column reference system that you use, etc. The standard one that we currently have here is the Google Maps one. That's, again, a de facto one that Mapbox uses. But OGC is also looking into supporting, there are more, and also to establish that and use that with other tiling schemes because, again, for example, from a European perspective, probably you don't want to necessarily use Web Mercator projection, but maybe also other grid systems. Inspire has several grid systems in there, so that should be possible when it gets to standardization at some point too. And then you can let's have a quick look at how we can at the tile metrics description. So currently we have just one in here. That's Web Mercator quad. That's the OGC name for the standard one. Again, I can let me just get it and put it in the browser. It's probably easier to see. So that's basically the description of the Google Maps tiling scheme. And you see here the different tile levels, how many tiles there are. On the outermost zoom level, you have just one tile. If you zoom in, you get increasingly more tiles. So that is accessible. Then also, and again, we're thinking on how to, that's what we did here is how to actually describe, make that accessible in HTML as well. The other thing that we're doing is actually styling. So currently there is also a draft for a style API that will be discussed then also over the next month. So here we just support Mapbox styles. So let's take an example. So that's in that case, it's again also JSON. So it's a style document for that Dara data set that we have seen that is hosted on the server. Get back here. We also do have metadata. The content is with thumbnails and some other more or less dummy information at the moment. In here, that's still work in progress. That will be more complete by the end of the month. But also here we show, that's again already another client that we see here. That's actually Open Layers that accesses that style from the Styles API. It accesses the tiles from the API and renders it in HTML. And that's probably could be quite similar to things that Jari can show. So one of the important things is, so we have one data set, but we're currently in the OGC web service environment. We do have separate services, and it's not really clear how they are connected. Are they using the same data? And here, basically in the API, where what we're doing is we do make the data available under the same API. So there is that styles API, and that's here you can also see some management functions, so I can create new styles, I can update the metadata, etc. So there is a lot more also for maps. There's work in progress for processes, basically WPS, and for coverages, and also for catalogs, or I call it actually records. We'll discuss that. There will also be a version that makes catalog available in a very similar API that what you have seen with features. So that's, I think, just a quick overview of the of some of the extensions that we're working on. That's all work in progress, and most of that is not yet or early in the standardization effort, so that will change. But you should expect probably some public reviews. I mean, most of that work is done in public GitHub repositories, so you can put in comments at any time. But there will be more public reviews probably coming up next year for some of these APIs. Any questions on the extensions before we move to Jari's demonstration of other clients? No?
Can you say a few more words on the extensions for the OGC API features for queries?
Yeah. So currently, what we discussed in the group. So there's one that is actually pretty mature because there is a draft available. Let me go there for two. Which we implemented and which you saw with the CRS and the Beatbox CRS parameter. That our hope is that we can progress that through the standardization process relatively quickly. So we want to get it through the internal architecture board review and then public review in the next month. And there are actually currently in the last meeting, TC meeting, what we agreed on beside the CRS one. The two things that we want to work on is filter capabilities and simple transactions. So when we say, let me get back to the slide that I had. I closed it. Because that's what you see on the left-hand side here. Part 2, that already has the part number because we have something. For the other ones, there are some internal things we need agreement from OGC that we can work on it. But query, filter, and sorting, there is that sprint coming up together with the catalogs group and Stack. I don't know who's aware of Stack here. Okay, that has a spatial temporal asset catalogs, and that is an activity that started in parallel to WFS3 or the OGC API things, where satellite imagery providers. So there are all these companies like Planet Labs, Radiant Earth, Digital Globe, who send their satellites, and also many of the smaller ones, and they're capturing millions of images to manage those. And so they came up with an activity to actually standardize it, because everybody was building their catalogs for that kind of thing. And they all were similar, but somewhat different. So there's not yet in any standardization group, but we were in good communication with them, and actually had our first sprint that we had in March 2018, we already did together with them. And basically the result of it is that their API to get to this metadata about the satellite images is actually conforming to OGC API-Features from the beginning. So, and they also, of course, they need capabilities to query the data in more detail than just the Beatbox thing or simple parameters. So there will be in 1 month, no, actually in 2 weeks, another 3-day sprint to actually work on a common way, because we want to keep the synchronization. We want to make sure that we don't implement something necessarily where we haven't talked to them, so that the things stay in sync, and then also in OGC API catalogs, because that's basically the same. And the current idea that in the OGC features group we're discussing is to actually use something like a simpler version of CQL. So throw out a few things. So CQL is the query language that has been used in catalog services. and which is basically plain text version of filter encoding, which makes it easier to write for some people, because it looks like a where clause more or less in SQL. And it works a bit better also if you put it on a query parameter in a URL. And basically we're leaving out more complex things that not everybody has implemented, like function calls or access to nested attributes, compound attributes. So, and that should be pretty straightforward to implement for most people. But that's one thing that will be discussed there, and that's at least one of the proposals that we have, and I think we will implement in our service in any case in over the next month or so. And it's also there won't be any mandatory one like we had in WFS, basically where everybody did filter encoding. And I would actually think to some extent sometimes it will depend on the backend. So if you have an Elasticsearch backend, you probably want to do something slightly different than if you have a relational database backend. So probably there will be some options coming, but one of the idea of that is to nail it down to what are the important options that should be there and are pretty straightforward to implement. And then again, for mutations to features, basically there we're also in this, we call it simple transactions, because it's not like in the current WFS transaction where you have the everything is committed or nothing is committed, which requires rollback or these kind of things. But we're basically just using the HTTP notions, just how you use post, put, delete, and patch to update resources on the server. We also, in LD Proxy, we have implemented that already, not on top of WFSs, but LD Proxy also supports Postgres as a backend. And if you have that, you can already activate, if you go to the manager, there's a way where you could actually activate that also already. Get back to our manager here. So API, here we go. So transactional, that's one of the options. You can see also some of the extensions are deactivated here, and some I haven't really discussed that. So we decided that these are the most important things we want to work on, and then we'll decide what's next. Probably another thing that I think will also be relevant that will come up is there is probably a new version of OpenAPI. So the current one is 3.0. There will be a 3.1 version around the end of the year, and I think we'll add a new conformance class for those who want to support it. One of the big benefits of that is, for those who have been following JSON schema and the developments, that will support the latest draft of JSON schema. Currently, OpenAPI uses an older draft and a slightly changed version, which creates overhead because you have to use two different ways of how you handle schemas in JSON. So that's another thing, but that's a more technical update to try to keep aligned with where the mainstream and their tooling is going. Any other question? No? Then we could switch to you, Jari.
And I believe we still have some time for questions after my short demo. It is also interesting to notice that OGC API-Features is already available, and there is a lot of ongoing work in extensions, and how the procedure works right now, that implementation is working in parallel with the standardization. So it is much easier to follow what Clemens just showed by styles and by tiles and other things, and you have a demonstratable demo there instead of PDF document where a lot of comments on the right hand side. So that's easier to communicate and then further develop the standard. I may repeat something, so just as this was a little bit of hands-on workshop, just what I said that if you are using Windows for Docker or Docker for Windows, you must share from your settings the C drive that you are able to run it smoothly and install LV proxy. So I also have one instance running here. It's slightly older than the version from what Clemens explained, but it's running locally. And I've set up 2 different services as well. One from OpenStreetMap POI data, which is actually my local GeoServer instance, for which you can, or that was not actually local, it's remote as well, but to have some OpenStreetMap POI data available. And then also I have the same a landscape atlas available, and what we already saw, we can look around to different features and browse it through the HTML. So that's one way of using the content, but there might be some people who are interested in using it in another clients as well. So quite good example could be QGIS. I have now some data from this landscape atlas here running, and you can click on the feature and then you can get all the feature attributes like in any other layers in QGIS. I have some bad news that the current version of QGIS, it doesn't support OGC API-Features, but I also have quite good news that Yves Roy from France has just a few days ago made a pull request to QGIS, which is support on a low-level OGC API-Features, so it will be no need for any additional plugins or anything, but when the pull request will be accepted, then there will be a nightly build, so you can use that one. And then later on in a new release it will be available as well. Not the next official release, so you must use nightly build. But itself already GeoJSON, QGIS is supporting GeoJSON. So what I made a URI request with a limit of 100, and then I just saved it on my local disk, and then I drag and drop into this. So if you would like to play around right now, you can do it like storing locally first and then put it there. But as I said, there will be a new version shortly in which you can use it natively via OpenAPI and put your URL there, and it will then find the content. I also found a bug from QGIS. Now I have this landscape atlas, one layer on there. It's available, and I have one selected feature. But if I disable this layer, there is still one selected feature, and I think that's not correct, because there is not such a feature right now. But let's not go into these details. Of course, another way of using these APIs is, of course, to have different web clients. I don't have that same style API available yet, so I'm using open layers, fixed styles, etc. But the main point is that you can have GeoJSON as an input format, and then you may have a URI with bounded box filtering available, and in this one I just used the limit of 200 features there, and I had some coordinate transformations because in our local instance developed by Janne, it's using national coordinate system, so but now it converts from WGS 84 to WGS 84, so that doesn't make anything, but don't worry about that. So as a result, what a surprise. Then you have OpenLayers client, that then you have content there available. So nothing extraordinary, but the point was that maybe during the last couple of years with complex GML, it may have had issues in showing it in different clients. I believe ArcGIS Pro and or ArcGIS Desktop is definitely supporting GeoJSON already, but not also API yet, but we can imagine it will be there at some point in time, and QGIS and OpenLayers, Leaflet and others. So that's my kind of short demo to show that you can use it already, and the standard is available. There are plenty of examples of running instances on the GitHub where the standard is as well. So there are around 6 to 10, less than 12, but I mean around 10 different implementations which are openly available, so you can play around and test these different things. And of course, as what Clemens just presented, a lot of future work is already ongoing, and of course looking forward to have those available as well. But by this I conclude my short demo thing. If you have any questions, we still have 3 minutes or even maybe a few more to have questions. We are staying here until the end of the conference, so if you have any questions or remarks later on, please find us. I'm quite easy to find, but so is Clemens. So thank you. Any questions?
Okay, any questions? Comments are welcome too. Yeah.
I just probably missed the information from your presentation, but as we now talked about the complex features, does this Open API support, let's say we have this data set with a complex feature type, can we browse through all the different parts of the data?
In general, yeah. So I mean, the standard actually supports that. So also GeoJSON doesn't. When you say complex features, I mean, when this is about, let's say, multiple values for an attribute or complex data structures, GeoJSON doesn't say anything about that. There are some GeoJSON tools that just do the more table structure thing, so it's just simple values, but the standard allows it, and actually we have several examples where we also have structured data. Of course, then when you get to an HTML representation of that, you get to new questions on how to display that properly, and that's also something that we're working on. But we have several organizations that we work with that play with it that actually have structured, more complex data in there. Yeah.
And there is also ongoing work in Inspire MIT for alternative encodings and simplifying the models. So that's maybe a new solution as well for something like that.
Any more questions? Okay, let's thank Clemens and Jari again. We will have a 30-minute coffee break, and then we'll continue up.